Aerospace R&D. Boeing and McDonnell Douglas from the United States and Airbus Industry, the European consortium, dominate the global aerospace industry. During the early 1990s, the end of the Cold War with the Soviet Union led to a dramatic downshifting in our orders for military-related purchases. At the same time, a global recession cut sharply into the commercial demand for aircraft. Against this backdrop, a number of financial analysts began to question the wisdom and profitability of the industry's massive long-term investments in research and development. The following table shows sales revenues, profits, and R&D data for a sample of firms taken from the U.S. aerospace industry. Data are for the most recent fiscal year reported as of May 19, 1993, and are limited to those companies reporting sales of $58 million or more and R&D expenditures of at least $1 million. R&D expenditures are the dollar amount of company-sponsored research and development during the most recent fiscal year, as reported to the SEC on Form 10-K. Excluded from such numbers is R&D under contract to others, such as U.S. government agencies. All figures are in millions of dollars. Using Excel, we're going to generate a simple regression model with sales revenue as the dependent Y variable and R&D expenditures as the independent X. Based on the model generated, forecast revenues for a firm with R&D expenditures of $300 million and evaluate the predictability of the model. Okay, so this one looks a little complicated and it's a little realer than what we're used to, but in some ways it's easier, but there's a trick. So let's go in and do what we were asked. Data analysis, regression. Now, the Y is the sales revenue. That is the dependent Y variable. So sales is our Y. Our X is our R&D expense, right? And I'll click constant is 0, labels is checked, we click OK. Input range contains non-numeric data. Now, if you looked at the data for a while, you might notice that these two numbers are left set instead of right set like all the other numbers. And if you look at it, you'll notice that instead of commas, somebody put periods here in the thousands place. And this is something you have to do sometimes. You have to clean up the data that you get, that you copied and pasted out of a 10K or off of the internet or what have you. I believe I fixed all the problems. Let me go and try the regression again and see what happens. So the X and the Y stay the same. We click OK, and we end up with R squared of 93%, and our p-values are well within range. So our equation would look something like sales revenue is equal to 16.879 times R&D plus 1379.4. Okay? So if we needed to predict, we would say sales revenue, and we would have something for R&D. So sales revenue is equal to this plus R&D times the R&D coefficient. So the question was with R&D expenditures of 300 million, so 300, we would have sales revenue of 6,443. Now, for the third part, evaluate the predictability of the model. This model has an R squared of 93, which means that this model accounts for 93% of the variability in this data. So we can be certain that the number that, or we can be fairly certain that the number that we get is going to have no more than a 7% difference than the number that we got in this equation, in either direction. And we can be certain, within 3%, there's less than a 3% chance that this coefficient has nothing to do with the equation, and there is almost zero chance that R&D expense is not related to sales revenue. This number here is 0.11018. That is the percentage chance that R&D expense is not related to sales revenue. So we are very, very confident about this model.